Colonel Aldrin and Mr. Armstrong. When President Nixon made his phone call to you on the moon, it looked like the two of you suddenly stopped doing everything and stood there and listened and talked to him. It looked there for a moment like you might have been a little bit aware of what was going on. You weren't busy. Was there ever a moment on the moon when either one of you were just a little bit spellbound by what was going on?
About 2.5 hours.
I'd like to ask Neil Armstrong and Buzz Aldrin, and I'm not quite sure how to ask this question, but when you first stepped on the moon, did it strike you as you were stepping on a piece of the Earth, or sort of what your inner feelings were, whether you felt you were standing in a desert, or this was really another world, or how you felt at that point?
Well, there was no question in our minds where we were. We'd been orbiting around the moon for quite a while. At the same time, we have experienced 1.6G before. We've been exposed to some degree to the lighting that we saw. However, this was, in my case, an extremely foreign situation with the stark nature of the light and dark conditions. And of course, we first set foot on the moon in the dark, shadowy area.
It's a stark and strangely different place, but it looked friendly to me, and it proved to be friendly.
There was a lot of discussion during the flight, during the power descent portion of the flight, about the program alarms and so forth. And I wondered if you all could describe your thoughts on the subject, how it went, and what advice you might have to offer the crews of Apollo 12 and subsequent flights for this portion of the mission.
Well, I think we pretty well understand what caused these program alarms. It was the fact that the computer was in the process of solving the landing problem, and at the same time we had the rendezvous radar in a powered-up condition, and this tended to add an additional burden to the computer operation. Now, I don't think that either the ground people or ourselves really anticipated that this would happen. It was not a serious program alarm. It just told us that for a brief instant the computer was reaching a point of being over-programmed or having too many jobs waiting for it to do. You know, a computer continually goes through a wait list of one item after another, and this list was beginning to fill up, and the program alarm came up. Unfortunately, it came at a point when we did not want to be trying to solve these particular problems. We wanted to be able to look out the window to identify the features as they came up so that we would be able to pinpoint just where in the landing ellipse the computer was taking us.
Buzz was carrying on a rapid-fire conversation with the computer at that point, but I think we really have to give the credit to the control center in this case. They were the people that really came through and helped us and said, continue, which is what we wanted to hear.
Gentlemen, you're about to take some tours, and I wonder what your feelings are. Is that perhaps the most difficult part of the mission, or are you looking forward to it?
Well, certainly the part that we're least prepared to handle.
What do you consider the most important piece of advice and recommendation that you will give the Apollo 12 crew before they take off for the moon in November, gentlemen?
I didn't hear the first part. The recommendations for 12 on which base?
Will be the most important piece of advice or recommendation for the Apollo 12 crew.
I think we can say that overall we wouldn't change the plan that we used or the plan that they intend to use. Now, there are a large number of individual details which we think could stand improvement, and we have had the opportunity in the past couple of weeks to go over those details and with the crew members and various people from around the program. In general, I'd say that we wouldn't recommend any major changes to the plan.
I have two brief questions I'd like to ask, if I may. When you were carrying out that incredible moonwalk, did you find that the surface was equally firm anywhere, or were there harder and softer spots that you could detect? And secondly, when you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
The first part of your question, the surface did vary in its thickness of penetration. Somewhere in rather flat regions, the footprint would penetrate perhaps a half an inch or sometimes only a quarter of an inch and gave a very firm response. In other regions near the edges of these craters, we could find that the foot would sink down maybe 2, 3, possibly 4 inches. And in the slope, of course, the various edges of the footprint might go on up to 6 or 7 inches, and compacting this material would tend to produce a slight sideways motion as it was compacted on the material underneath it. So we feel that you cannot always tell just by looking at the terrain what the exact resistance will be as your foot sinks into a point of firm contact. So one must be quite cautious in moving around in this rough terrain.
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar corona what stars we could see.
I don't remember seeing any.
Neil, you were a little bit concerned, you said, about stubbing your toe at the point of landing because the surface was obscured by dust. Do you see any way around that kind of problem for future landings on the moon?
I think the simulations that we have at the present time to enable a pilot to understanding the problems of a lunar landing, that is the simulator and the various lunar landing training facilities and trainers that we have will do that job sufficiently well. Above that, I think it's just a matter of pilot experience.
This is for Neil Armstrong. You said early in your presentation that masculine W occurred about 3 seconds late, giving you the clue that you might land somewhat long. Now, this was before you got to Highgate, so that it had nothing to do with maneuvering to find a suitable place to land. I'm wondering what would have caused this 3 seconds late. Did it have something to do with the time that you began powered descent, or what?
Well, the time that we started powered descent was the planned time, but the question is, where are you over the surface of the moon at the time of ignition? And where that point is largely determined by a long chain of prior events. Tracking that's taken place several revolutions earlier, the slight maneuvers that have been done in checking out the reaction control systems, the undocking and the ability to station keep accurately without ever flying very far away from where the computer thinks you ought to be at that time. And of course, the little bit of dispersions in the maneuvers, such as the DOI burn on the backside of the moon that were not quite properly measured by the guidance system. Now, each of those things will accumulate into, in effect, an error, a position error at ignition, and there is no way of compensating until you get to final phase for that error.
Based on your own experience in space, do you or any of you feel that there will ever be an opportunity for a woman to become an astronaut in our space program?
Gosh, I hope so.
I'd like to refer back to something that Neil Armstrong said a while back, that there was so much out there you would like to have done. As it was, you ended up a considerable number of minutes behind schedule. Is that because the schedule was overloaded for the EVA, or can we expect all astronauts, when they reach the moon for the first time, to enjoy themselves and spend as much time doing so as you seem to?
We plead guilty to enjoying ourselves. As Buzz mentioned earlier, we're recommending that we start future EVAs with a 15 or 20-minute period to get these kinds of things out of the way. Get used to the surface and what you see, adapt to the 1/6G and maneuvering around, and probably we just included a little more in the early phase than we were actually able to do.
Two questions. Where did the weird sounds, including the sirens and whistles, come from during the trans-Earth coast? I believe ground control had asked for an explanation, saying it had come from the spacecraft. Secondly, I understand although low-angle lighting caused no problem walking around, there was a problem seeing obstacles in time when traveling at high speeds. I understand this might indicate the need for a flying machine rather than a rover for a long-distance lunar surface travel. Can you explain this?
We're guilty again. We sent the whistles and bells. We had a little tape recorder, which we used to record our comments during the flight. In addition, play music in the lone.
Many of us and many other people in many places have speculated on the meaning of this first landing on another body in space. Would each of you give us your estimate of what is the meaning of this to all of us?
You want to try that?
After you.
Well,